Okay, hello. I am Dominic Sander, and this is my Stat 351 screencast. Um, I was going to do something over APIs and scrape the data from a Bible.api site. However, for some reason, there was like a major update with the site or something, and I lost my API key, and so I had to request it again and still haven't gotten access to it. So instead, what I will be doing is I will be scraping uh, data from an open Bible site, and I will be playing with that for this project. So, just to start with, I was just going to set up everything, and then here's the link to the openbible.com, and then they have a downloads page. So that's just what I'm starting with. I have my pseudocode here for some stuff. Um, we'll get to all that later. I'll just run all of my libraries and then download the URL so we have that for later. Um, First, I will just start with what an API is because I was planning on using that. Um, but basically, an API, when you're going to a site that has an API, you can sign up for an account on that site and get a free API key. Then that key allows you to make calls to the website and scrape data from that page. It does that a lot easier and a lot smoother than a web page that doesn't have an API. It also tracks your usage of the website. So if you go over a certain number of calls in a month or in a week or something, um, you aren't allowed to make any more calls unless you pay for it. That's because a lot of web scraping is hard on the website. So it can take a lot of time and even for the website money if so many like people are scraping it, which is why a lot of websites will set up this API key. Um, so if a website has an API key, you want to use that key. You want to sign up and get your key so that you can scrape from the website. Trying to scrape from a website without using an API key when they have one available is not good. It's kind of unethical because they're saying, hey, these are the terms and conditions for our website. If you want to use our data, you have to go through it this way. And by trying to circumvent that, um, it's not a good look. Um, So another thing, I wasn't originally planning on doing Bible data. I wanted to do maybe some sports data, which I know isn't like the open data like the project had initially said. So I had my site. I thought I found everything. I looked through the terms and conditions for using the site, and I thought it was good to go. And then when I started working on it again, I saw something that said um, no web scraping allowed. Period. So obviously, I had to abandon that. Trying to scrape from a site when it is explicitly barred is something not good people do, and we are good people, so we aren't going to do that. So I had to go look through different sites to try to find an API key or try to find just an open source that I could scrape from. So we'll get into the code now. Here I have the setup. These are all the packages that I think I'm going to use. If I don't end up using them, great. If I do, great. If I need to call more, I can. This is just kind of what I thought I might need based on what we'll be doing. So first, we're going to extract the data. I had a little bit set up here. So we have our URL, and we're going to get a page by reading HTML. So that's in the HTTR and HTTR2 packages. And Arvest also does a lot with that. I could have grouped them together and be like, here's our scraping packages and all that. But I didn't do that, so I apologize. But we have our page. We'll do read underscore HTML of our URL. And that gets us something that isn't very beneficial. You can't really see anything here. It's just a list. What are you going to do with that? There's no data in it. So what we want to do then is we want to get the links from the page, because I guess I can show you what the page looks like. This is the page. So obviously we want to find the links from this and then scrape. This is like just the Bible in a bunch of different versions. So I was kind of interested in like, oh, how do these versions differ from each other? Is there anything crazy between them? Specifically, I was curious about the American King James Version, the American Standard Version, and the King James Version, just because those are ones that I have seen or used in my church or in churches that I'm visiting with. I was really hoping they would have the new revised Standard Version on there because that's what my home church uses, but that's fine. We'll get back into R. I've also got my sports media things here, so if I click into them, I'm sorry about that. Um, So what we want to do here is we want to take the HTML elements from our page that we just created, and we want to do that by finding the hyperlinks, which I just showed you, which I believe is just an A that ran. So if we're looking at links, we've got a list of 78, and 78 seems like the right number of links that we saw. And then you can see here in the attributes that we have the openbible.com, and that's the Bible XLSX for certain version. Here, same thing, but it's the BSB version. So I think that's the Berean Standard Version, or Berean Standard Bible, or something like that. So we got that. And then we want to create the files from this links. So we're going to be doing links HTML underscore attributes, because we're looking for the attributes from the links. And here, the XML attributes, but it works. And then to get that, we want the href, which is we'll call like the URL from those links. So we'll do that. And now we have files with this. We have the openbible.com \xls Bible. So we've got 78 observations, and that's how many links we had. So that's great. Then we will just go ahead and run this next line that I had set up. We want to get the names from those. So we'll just take the text from that title. We get names, and 1401 Bible Database is the name of like the first observation or the first link. So we aren't going to need that one, but that's just what they're going to look like. So that's good. Then we want to create a data frame using a name and file that we get from the names and files here. So we are going to do name equals names coming from here. So we'll get this into a data frame or a tibble data frame. They're the same thing to me. And then file is going to come from our files variable that's from up here, df, and let's see what we have. Beautiful. So we have the name of the file, and then it also has like what form it's in. So Excel, PDF, Word, all that. And then we have the file link. Woohoo! Next, we want to create the DF. I wanted to create the data frame of just the Excel files because everything on the page was basically repeated just through different files. So there's Word, there was PDF, there's Excel. We have the read Excel function, so I wanted to pull that and only the Excel files. So creating the DF Excel, we create our data frame from above. Then we're just filtering it for a file that has XLSX in it. And this is what a regular expression looks like. So the 2 backslashes, just call it, and that's what we're looking for in here. I believe the $sign ends it. If we're being honest, I don't have those memorized, not even close. So I had to look up how to call a specific part of a string. And that's what I got. Let's run it. And beautiful, we've got 19 Excel links, and we have the link and the name. So then I want to call the actual, what's it called? The links from the data frame I have up here. So I'll just take the American Standard Version, copy, paste. There's probably an easier way to do this, but the easy way isn't always the easily understandable way for me. So I'm just going to do this. We'll be fine. So we'll do this, add it in there. So then these are our XL links. And we've got the 3 characters there. Okay, so then we want to I was going to do a for loop for these three to put them into Bible links. I already created that just to make sure I could get them in and read them in properly. And then I could look at what I wanted to graph with them later. So I cheated a little bit by going ahead. But um, what we want to do here then is for loop for these items in XLSX underscore links. So that's what I'll put here. SX underscore links. And then we want to create the file name. And by doing that, we're going to be pasting the Bible underscore links in front of them, and that will put them into the Bible underscore links folder we have. Then we will get the links, right disk, file name. That puts them into the folder there. It took me a while, but I finally figured out overwrite equals true has to be on for it to actually go in. Um, I think I got an error message that said overwrite is false, and it still took me 15 minutes to figure out that maybe setting that to true would fix my problems. So we're going to do that for loop here. Beautiful. And then we are going to just look at our Bible underscore links and look at that. We have the abbreviated version and then the XLSX for our American King James, American Standard, and King James. So that's all good and well. Now that we've got the data in the working directory for us to use, what we want to do is start to read it in and clean it. So then what we're going to do is we're going to create a new variable called, actually, wait. I have in my notes that I wanted to touch on polite techniques for acquiring data, which I kind of already did in the beginning. So I really don't think I need to add anything here. So I apologize. We don't need to wait. Let's keep on going. Okay, so what I'm going to do here is just, honestly, before I even do this, let's just check out our data. Let's do like pull this up again. Like let's call the American King James Version just AKJ, and then read underscore XLSX. We'll be able to read the Excel file. And then this is what we have before. Oh wait, let's just try this. Tab, Bible links, and then we have akjv.xlsx, and see if that works. Yay, it reads in. There are 31,103 verses in the Bible. Oh, we do have an NA up here, though, so we'll need to get rid of that. 31,102. But then this should be able to tell us everything we need to know there. So that's exactly how we want it to look. Let's do that for the others. ASV is read underscore XLSX. Tab. Oh, here we are. Let's do that instead. That's handy. And then KJV read underscore XLSX. Let's do that once more. KJV. Then if we look at ASV, it looks the same, wonderful. And then if we look at KJV, it looks the same, wonderful. Let's kind of get rid of some of these here that we don't need anymore. Okay. Now let's actually get into reading that Excel. Oh, we already did that. So we can honestly just kind of... I could have just not done that. That's okay. We'll just add this back in. Do AKJ. It's AKJ using our dplyr pipe. Then we want to mutate to get the version. So AKJ here. We have the American King James version. So that will end up being, let's just call it AKJ. That'll make it easier than trying to spell out the whole thing every time. That's going to be a pain in the butt if we do that. And then text equals, let's do, so the text is what I want to call this. I want to call this text. So we need to do AKJV is equal to text. Ooh. Try this. AKJV is equal to text. And then I also have the regular expression. So we can see here, Genesis 1:1 is all in one column. That's not going to help us in the long run. So what I want to do is I want to split this into a column that's book, call that Genesis, a chapter, and that'll be the number before the column, and then verse, and that's the number after the column. So what we will do then is we'll create this regular expression. Once again, I looked it up for like the digits and everything before the first space. And so that's what this is. This is everything before the first space, or the last space. The last space. And because there's only one space in here, that's in between Genesis and 1. So everything before that. And then we've got our digits, and that's before the colon, and then we've got the digits that are after the colon. And then what we need to do is this needs to be a part of an extract function. We'll do that. And then what do we got here? We want to extract this column into those three. So we're going to extract ... 1. Okay, that's interesting. We're going to do this, extract ... 1. Oh yeah, I'm in the union, by the way. So if you hear people talking, it's just them in passing. I needed to get this done tonight because I knew if I tried to do it late tonight or Saturday morning, it would not go over well. So we're doing that right now. So we need to turn this one into, and then we want that book, chapter, verse. So we'll do, let's just get that out of the way. Into, we'll need to do book, chapter, and verse, and we'll need to concatenate these because we've got 3 different thingies. And then we got the comma, and then we got the regular expression to turn it, get rid of that, get rid of that, get rid of that. And then I also do a little bit of playing around with just an example regular expression. Convert equals true. We'll turn it into a numeric instead of a string if it is numeric. So that obviously will help us make this look better with like our chapter and verse numbers so that we can actually call them, or we can work on them later if we need to. So I'll run this and see if it works. Does not. Okay, column text does not exist. That's here. Oh, we want text to go in there. Okay, it's backwards. AKJV. Text. How's that look? Book, Genesis, chapter 1, verse 1 through. It's beautiful. And then we've got the text in the version. Let's look a little further. Make sure double digits looking okay. And we get to maybe. Goodness, Genesis is on. Exodus, where are you? Oh, I apologize. I thought this would be a lot quicker. There's Exodus. And is it looking right? Yeah, we're looking good. Okay, I'm happy with where this is at. So, let's scroll to the top just in case. So we still got these NAs in here, not what we want. So, let's just get rid of them. I don't see an issue with that. So, Let's go na.omit, and then it's just for our AKJ, and see if that does the trick. No, AKJV doesn't exist. Oh, I think because I did it all in one. Let's try that again. There we are. Just had to rerun it and set it back to the way it was before. Just because I renamed it, I can't rename it again if the old column doesn't exist. So we have our NA omit, and look at that. I'm happy. Okay, and then we need to count the words in each verse because that's what we'll be kind of playing with when we do our graphs. So let's do it. Just AKJ is AKJ. And we want to mutate. We're creating verse words. That tells us the number of words in each verse. Then we're str counting the text column, and then our boundary is just the words. So our text column, it will count how many words. So we should see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words in the first verse. So let's try that. AKJ, we get 10. And look at that. It does that for every single verse. 29. So this one obviously goes on a little further than the other ones. Beautiful. And then I also want to create the number of words in each book of the Bible. So for Genesis, I want to see how many words are in Genesis. Exodus, how many words are in Exodus, so on. We'll just call this AKJ, AKJ underscore book words. And that will be using our AKJ. Nope. Then we want to group by book because that's what we're going to be, that's what we want to group by. We want each book to have its own observation. And then using summarize, we can do total words. So that's the total words in each book equals the sum of, that was our verse words that we created up here. And do sum of verse underscore words. And then we want to drop the groups because if we keep them grouped, it won't look the way we want it to. So let's look at AKJ book words. And look at that. So this is in, oh gosh, what's it called? It's in order. It's in the, oh my gosh, I'm so sorry. It's in alphabetical order. There you go. With the numbers first and then alphabetically. So obviously that's not quite what we want, but that's okay. We can look for Genesis and see 38,298 words. That's a lot. Let's look at maybe like Psalm, 42,000. I knew there'd be a lot in there. Jeremiah, another 42,000. Ezekiel, 39,000. So there is a big variation between like the big ones and John that, or Second John that has 298, or Jude that has 608. So interesting to note. Okay, then looking back on it, this was kind of like a last second addition to the pseudocode here. I thought, dang, this would suck to do for everything. It really wouldn't. I could easily do it and be just fine. But there has to be an easier way, right? So I thought, hey, let's create a function for it. So we'll do the data frame. The function will be data frame and version name. So I will call in the data frame like AKJ and give it a version name. And then that will hopefully get us, once I add everything back in here, back into get us like AKJ book words for all of them. So what we will do, we'll start out with our function data frame version name. So we'll take our data frame, and then what we'll do is we will just kind of, I might just copy paste into here. Now, this may not be exactly what I need to do, but I'm gonna kind of look through it. Need our mutate version equals AKJ. Um, we don't need that. I don't think we're not going to be mutating by putting the version because it's going to be different for each one. So do rename text equals AKG. I don't think I need the rename because I'll be. I think I just need to do all that individually and then do yes. Okay. I know what I'm doing. Okay. And what I'll do then here, it's not gonna be the prettiest. It's not gonna be the quickest. Probably not even, definitely not even the smartest. But what I'm going to do is I'm just going to change this to ASV. So then we can just get it into the form that we want it to, and then we can apply our new function that we're creating, and then we put that onto the ASV file that I just updated. So that's the ASV text equals ASV. And then we got extract, yep, into, yep, and NA omit for our ASV. And then do the same for AKJ, or oops, for KJV. King James version equals KJV, text equals JV, and down here, KJV. We'll do that, and hopefully ASV looks yay. And then hopefully KJV also looks the same. Beautiful. Okay, then I'm going to do the mutate statement here into this function as well as this group by, and then hopefully, do that, and hopefully we can just throw that in here. And let's see if that does what we want it to. Word counter, okay. So now let's try that word counter on our let's do our ASV and see what that gives us. Hey, look at that. We have our ASV. I do want there to be a column with the version name, though. Because if we don't have that, then when we put them all together, we're not going to be able to know what it is. So let's just write a mutate statement for that. Mutate should just be version equals, what do we have? Oh, version name. Yes, that's what I was. Yes, version underscore name. That way, we'll put in our version name when we create our data frame, and then we will mutate and create a new column called version using our version name when we put in our data frame. Let's try that. Word counter, and then we got to do ASV, comma. We want to write it like American Standard version. See what that brings up. Hey, and that's exactly what we want. We want the American Standard Version, total words, and book in our columns here. Okay, now let's just do that for all of them. I know I already created the AKJ book words, but let's just make it the same for all of them. AKJ, American King James, and a word counter for KJV, which is King James Version. Oh, let's do this once that. Oh, okay. Well, we got King James Version looking good. American Standard Version looking good. American King James also looking good. I need to name them. So let's go AKJ counted is word counter da 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 da. ASV counted word counter, and KJV counted word counter. And on that. And if we R bind those, because we knew we'd need to combine them into one data frame eventually if we wanted to make our graphics, we will have to put AKJ counted, ASV counted, and KJV counted here. And beautiful. We got our R bind, hopefully. Let's see. King James Version, awesome. We should name that too. Let's put that as all underscore counted. And now, looking at that, we have it. You have 66 books for 3 different versions to get, or 66 books for 3 versions. Then we are going to move down, where were we? Here we were. Then we've got the data that we kind of want to use. So let's create our interactive graphics. Before we do that, I just wanted to touch on what an appropriate graphic is, how to use it, that kind of deal. Just some of the basic things about appropriate graphics. You want to have just clear labels for everything. You don't want to have like abbreviations or something that someone's not going to understand. Color can be a big issue. Some people are colorblind, and sometimes color is just way too much on a page. So what you're going to want to do is make sure you're sparing in the use of color, make sure it's purposeful and like looking good. Then you also want to avoid clutter on the graph. So if you're graphing too much in one place, it's just not going to work out. And then we're also going to, I also want to talk about real quick, just color blindness in general. You want to be colorblind friendly when you're creating graphics. So something you can do with that is to not use a rainbow scheme, just because using all the colors of the rainbow, if someone is colorblind, whether that's red, green, or another type, they aren't going to be able to distinguish between those colors as well. If you can use a monochromatic color gradient, that's really easy to determine just what the differences are. So obviously, if you can't do that because you have multiple discrete variables that aren't um, measured on the same scale, that's fine. Um, but when you can use a color gradient, a good rule of thumb is if you can understand what the plot says in black and white, like if you change your plot to black and white, then it should be good to go. It should be readable for anyone, colorblind or not. And then just another thing, if you can, use shapes when possible. So if you're like creating a dot plot that has 3 different colors and sometimes those dots overlap, creating a shape for like if you have 3 variables, circle, triangle, star, that helps distinguish the different other variables that you're measuring. Um, I remember the Palmer Penguins data. We did that when looking at back the book that Dr. Vanderplas wrote. So then what we're going to want to do, I brought in the CB colors. That is a colorblind friendly scheme. I can't remember what it's called. It's like the O for, I feel like it started with an O or something. But these are 3 colorblind friendly colors that work well together. So I just brought those in because there's no way I was going to memorize or remember those hex codes. Next, we are going to just create our plot. So we'll just use our data, all underscore counted. Then we want to use our aesthetic. And then I think I'm going to do a per chart for this, and it's going to be like a side-by-side bar chart. So we're going to have bars for each book for American King James, American Standard Version, and King James Version. We'll do ASX equals book, so that's what we want our x-axis. Y is going to be our total underscore words. Our color is just going to be our version that we had in there. And we want to group by that version as well. Then let us do our geom underscore column. I think that's all I really need. Why does it keep doing that? Oh, duh. Let's do that instead. Let's do theme underscore minimal. Having a minimal theme is also good, especially with the gray backgrounds. It'll help, or without the gray backgrounds, it'll help colors stand out better. And then let's try that with our scale underscore fill underscore manual. See, value equals CV underscore colors. See if that tells us anything. Okay. Did I run this yet? Values is missing. It's supposed to be values. Yeah, it was. Okay, now let's go ahead and just look at our plot. See how it looks. Great. Not really what we wanted there. I mean, this is fine, um, but it really does not help us distinguish between them. And this is obviously a mess at the bottom. So let's try. Our geom call is going to be it's like identity or stat. No, maybe it's stat equals. Let's go to L. See if this tells us anything. Bar charts. Oh, position. We don't want position equals stack. We want position equals dodge. Let's try that. Let's try about that in quotes. Okay. Oh, there we go. Hey, that's looking better. We still don't really want the gray fill. Um, and obviously we're not seeing a whole lot of a difference between these, but that's okay. That's a problem for later. Instead of doing color equals version, let's do fill equals version. That should hopefully get rid of. Yay! There we are. That's exactly what I wanted to see. And then I'm going to move the x-axis. I believe that's under the theme. Axis text X. I did write that one down because I have not used that ever, I don't think. And that um that should be equal to element underscore text, I think. Conjunction of the theme system. Yep, a themes. And then text. We want the text of our x-axis to be rotated. So we want the angle, do angle equals 45, put it at a 45-degree angle, see if that helps, and see what happens. Okay. Let's try just a nice 90. And let's look at our plot in a new window so we can actually see it all together. There we are. Okay. I'm liking the way it looks, except our x-axis here. It doesn't look like the books actually line up. They're kind of overlapping big time. So let's exit out of that. And I think we can use our justification. So something like uh, HJust is horizontal justification, which like moves it left and right. So if we do HJust equals 1, see if that moves the way we want it to. Okay, still not quite there. Let's try h just equals -1. That might work better going in the left because it was all shifted to the right. Oh, let's load. Well, obviously that didn't work the way I thought it would. Should be VJust or yeah, vertical justification, right? Oh, maybe it is because it's all rotated vertically. Let's try that -0.2 instead and see if that will tell us what we want. And that's looking a bit better, but maybe a little bit too far back to the left. Sorry, this is just kind of a Gibson check right now. Try 0.1 and hopefully, I mean, it's looking pretty close. Max, let's try. Oh, it looks like the justification isn't even necessary. Where are we at? Here we are. Our pot there. See, let's try H just once more. I may have done something wrong with that. H just equals 0.1. Let me see if that helps. No, I think I'll be okay with this. I'm not too mad. Obviously, it's not going to be the best that you've ever seen, but it is alphabetical order on the bottom. So you see First Chronicles, First Corinthians. So if you're looking for a specific book of the Bible, we can certainly find it. Um, but then if we're looking for like the highest, we can arrange that. And I'll do that later. What I will do right now, though, since shocker, am running out of time, or threatening to go over time, I'll just use Plotly. And to do that, I'll scroll back up. You just use ggplotly of the plot, and that's using the or the plotly package there. So doing the ggplotly allows us to hover over and get the names. So like version, American King James, total words. So you can see like here there's a fairly big difference between King James version, which is 43,739, and American King James version, which is 42,743. Um, so that just kind of tells you that's what ggplotly does. It allows you to hover over and get more info about the data. You can also scroll on it, which is nice. Get back to there. You can look and highlight a specific portion. And then you can zoom back out. Um, I don't really ever see a use for that personally. At least I haven't for this. But I guess if you wanted to look at like, oh, here are the lowest ones, so 299, 298, 298, 442, 430, 434, stuff like that. You could definitely zoom in. And you just double click on the graph to get back out to the original. And then what we could do is just do something like all underscore arrange descending all underscore counted, or actually let's do all underscore counted arrange descending by, say we just wanted to see total words. Okay, that's not what I wanted, and that's just fine. What I will do then, just create ranged all underscore counted by version. This group by may not be necessary, but I'm going to do it just in case. Then range descending of total underscore words. Okay, and then let's just do ggplot of arranged. Oop, that's not supposed to be there. Let's try arrange of that and see if that does anything different. Okay, so these are aren't numeric, which is why they're coming up as issues. So let's just do arranged $sign. It's total words. It is dot new. Let's do as dot numeric. That better. Of arranged $sign total underscore words. Okay, now let's try that. That's double. Ah, should be fine. Okay. Okay, I'm not going to try to spend too much time on this. I'm sorry. I did want to get it into like a descending graph, uh, or in Bible order too, like just the regular version. Um, I am already sitting at like 40 minutes, I think. 50 minutes. Oh, I'm at 50 minutes. Okay, let's move on. This is Shiny. So what I did here, I took code that I found on Stack Overflow that was literally, not literally, it was very similar to what I wanted to do with my graphics. So I'm just going to adjust this. I did some playing around, and hopefully we can get this to run as well. What we have here is their data frame, which we don't need because we've already got our all underscore counted. So what we will do is we want to create our user interface and our server. Um, if we run these together, it should hopefully get us the um, interactive plot that we wanted to create. So I will just kind of adjust this the way we needed. So I'm trying to create basically a bar plot that allows you to put in uh, whichever books and whichever chapters. No, whichever Bible and whichever book. Sorry. So we'll do like this one should be version and select our versions. And our choice will be all underscore counted in version. So we'll create all underscore counted $sign version. Multiple equals true, and then the options, these are just what we're going to create with our interactive graphic. And then the same goes for here. We don't care about states. We want books. Select books. Unique all underscore counted of books. And we want it to be bar. Yes. Okay. Then we create the server, which is going to have an input, output, and session. I think keeping this in here is a good idea because you need to request everything that you're going to be using. So obviously we want this to be counted. Oh wait, that's part of this input. I'm sorry, I lied. We want this to be input because that's part of this. Input $sign or versions, and we want input $sign or books. And that way we can actually call uh, these columns when we're creating our interactive graph. Then we want to bind, stack, the data frame, select input $ versions. Oh, I went too far. There should be books, maybe. And this one's versions. Books input $ books. That's a good choice. I did have a second um, piece of code that I got from Stack Overflow as well, that was similar to this. So I might try to combine and see if that works. I have it written down on what it's supposed to do, kind of. So we'll try to run this and see if that works. So let's have our output bar. It's going to render our plotly. Request that. Beautiful. P plotly filter df x is not, and it's going to be our book. Y is going to be total underscore words. Text going to be bar. Color is not going to be in states. It's going to be a version. And then we also want to have, I got this from the other one. Text is approximately paste words. And then we want that to have total underscore words. And then this isn't necessary, but I think we could do it. The hover info equals text. So then if you hover over the graph, it'll tell you what the text is from our paste words, total words here. So hopefully that works. And then we also want to have a layout of bar mode equal our group because we're grouping it. Then x-axis equals list, check angle equals maybe 90. And this all just made it look better when I did. I like copy pasted some code from an example, and that just was kind of basically graph cleaning to make it more, to make it look better, if we're being honest. Okay, and then Shiny App UI server, that just creates our app. So let's run this code chunk and see if this gives us something. Well, it's something. Okay. That at least tells us the versions. We can click which versions we want. We can have 1, 2, 3. We can click the books. Okay, we can't click the books. Okay, we'll look at that. You can't type there, so I could do like the jobs, see if that does anything. It doesn't. Obviously, our biggest issue, our entire bar graph is there. So I will pull from the other one and see if that works. I will take a second to mention with our Shiny, you can actually create a UI file here. So if we go back to our files, I could theoretically create a new folder, call this like Shiny App, click OK, creates our new Shiny app, and then I can add a new like R script called, we'd want that called UI.R. And then we could also do a new R script for server.R. And then I could theoretically copy, let's just copy this and see if it works. Doesn't hurt to try, you know? And then I don't think I need this because we did that. I've done them both and I just don't remember. They both worked for me. So, and then we can just run our app. Oh, you're so right. I should be saving this. Okay, now we're running our shiny app. Okay, it gets us the same thing. So those are just two different options to get to the same place. I'm just gonna delete these since I won't need them. Delete that, yes. And then if we go back to our shiny, and then we can just delete our shiny. Not necessary. anymore at least. Okay, I will do a little bit of adjusting. Um, what I have written down is changing this filtered DF stuff. So we could do filtered versions, combine stacking versions. Um, oh, duh, this is calling the old thing that we don't even care about. Let's just run that. See if it works. If it doesn't, oh well. I got a couple other things I can try. Okay. Same thing as before. Okay. So then what I will actually do, I will remove this C bind. I think it just depends on the type of data that you have. So since my data is in a data frame, I would think it would be the same as the other data frame for the example. Um, so let's just go ahead and call our all counted and use that to get our data. And filter version has to be in um, this. So we want to make sure that what we have is in, like, this copy of version is in our requested. Because if it's not in our requested, it won't run. So we're going to filter our version in that, and our book in our percent input $ books. And I also just want to go through and make sure counted version, yes, books, select books, all counted books. Make sure I didn't miss anything. Filter DF, input books, rec filter DF, plotly filter DF, book, total words, type as bar, version. Okay, I don't like this, if we're being so honest. But it will be okay. Output bar, render plotly. My biggest thing is it doesn't give an error, so it's not like it won't tell me. I want my output to be a bar. Multiple is true. Options is the list of our plugins with our remove button. Plotly output should be a bar, but it's not. So which makes me think there's something wrong with the all counted where it can't count our all counted. We have our version total words. Choices unique. Filter DF. It's supposed to be reactive with a request for our input versions and our input books. All counted, filter version should be in this, and our book should be in that. And then we can use our filtered data frame here. We request it. Is this even necessary? Can I just delete this? Let me check out this second example, see if there's anything that looks like it would be helpful. The text is paste. I mean, it's supposed to just plotly all that. Oh, wait. Yeah. Plotly. Yeah, no. Let's try that. Okay, still nothing here. So let me just try saving. Oh, unknown or uninitialized column of books. Book. It needs to be book. It needs to be book. Um, uh, book. Oh boy. Now we've got something going. It might just be that one because the other one I called from this books thing that I created. Oh, look at that. We've got our books that we can select too. Still actual bar chart. Um, let's just render this. I want to see what it looks like on our actual rendered page. Let's see if that gives us what we want. Execution halted. Okay, unnamed chunk 4. 104, 125. Oh, okay, yeah. We're gonna get rid of this range. I'm sorry. I wish I could get that to work, but I'm already at an hour and I don't want to go really any further. Um, so we're just gonna get rid of this arranged. But no, that's what I would do next. Yeah, I can talk about what I would do if I had a little more time. I would arrange this by probably decreasing. So I create this bar chart with the highest count on the left and the lowest count on the right. I could even create, like, mutate from each version and create a mean. Okay, we still got here. Um, okay, I'm just gonna run this all again just to make sure I get everything back in the right form. We don't need uh don't need it in numeric right now, so we'll be fine. Yeah, but as I was saying, I would put this in like a decreasing order here. I would get that darn uh shiny plot to work. Shiny is so cool and so useful, but so difficult, especially if you don't know exactly what you're doing with it, which I don't. So let's try rendering this once more, see what we get, and then I'll wrap things up. Okay, still object arranged. Okay, okay, I keep forgetting. That needs to be our all content. Please, dear Lord, work. Yay. Okay, we get a warning that our Shiny application is in a static R Markdown document. Oh, so maybe I should be creating that uh, over here on the side. Create the file. Um, yes, I probably should. I'll do that, and then we'll call it good. But hey, here's our package. We got a Plotly package. Now this one obviously isn't quite as good as when we do it full screen, but we can zoom out if we want, zoom in, and check on specific books of the Bible to look at the data that we want. Yeah. What I will do, I will go back here, create a folder called Shiny App. Create a folder called our Shiny App. Okay, I just did it wrong. There we are. I just need to reload. File, rscript, UI.r, file, rscript, server.r. We got UI, and we got our server info. Let's just try that. Oh, and I'm running a little low on battery, but that's fine. We are almost done. Save that. Save that. Then we can render it. Oh, that's my index. Oops. Okay, well, there's my index. I apologize. That, we're good. Let's go back to Screencast, public data, and render our code. And then we can also render the Shiny app if we really wanted to. Um, yeah, but there I'll kind of leave it off with like I would love to look further into the books of the Bible, descending, ascending, and that graph. I could look at specific instances of words in each chapter or words in each Bible, so we could see if like the word God is used more in one version versus another. We could see if the word faith is used more. Uh, we could also, if we really wanted, find like maybe an open Quran site or an open Torah site, and we can compare which words are used more frequently in each of those. So, like, I believe the Bible would use Jesus a lot, especially in the New Testament, whereas in the Torah, Jesus would not be mentioned because I believe it was written before him. If I'm getting my theology correct. And in the Quran, Jesus is he is a prophet, not the Son of God. So he's probably mentioned, but probably not quite as much. So that's something I'd like to do, look a little further into, if I can. But here we have our code. We rendered it. And yeah, the application is not supported in the R Markdown file, so we would just run our app uh, and get that going. And with that, I will cut us off because I'm already sitting at over an hour and 5 minutes, so I'm sorry for whoever has to watch this. I will get everything set up and uploaded, and have a good rest of your day, whoever's watching this. We will stop recording.